In this video, we will be discussing limits. And the notation that you guys will be using for limits is this one. And the way you read this is limit of f of x as x approaches c equals L. What I want you to do right now is press pause and copy this down. Okay, so limits can be used to describe how a function behaves as the independent variable moves toward a certain value. Let me go ahead and explain that with an example. Consider this function, x squared minus 1 over x minus 1. Think about the graph of this function. What do you think the graph of this function will be? Pause the video, think about it. If you remember your basic algebra, you can factor the numerator x squared minus 1, and you'll see that x minus 1 with x minus 1 will simplify. So we're left with f of x equals x plus 1, which is a linear function. Now, another thing that you should have paid attention to is the denominator x minus 1. So we know that we have a constraint here that x cannot equal 1. So what does the graph look like? The graph is just a linear function, a slope of 1, y-intercept of 1. However, we have that constraint that x cannot equal 1, so we should have an open circle at x equals 1. Now, I want to consider the limit of f of x as x approaches 1. Now, x equals 1 is right about here. Now, when you are considering the limit of f of x as x approaches 1, I want you to consider the left side and a right side of f of x at x equals 1. So the left side of f of x at x equals 1 is this part of the function, and the right side of f of x as at x equals 1 is this part of the function. Now, as both the left side and the right side move closer and closer towards x equals 1, we seem to be getting the output value of 2. So the limit of f of x as x approaches 1 in this case would equal 2. That's your answer. Now, don't get this confused with f of 1. F of 1 is still undefined. This is the limit. The limit of f of x as x approaches 1 is equal to 2. And a quick recap, we just pretty much take the left side of the function f of x and the right side of the function f of x, and where the two sides meet, that's the limit, that's your answer. The output value would be your answer. Now I'm going to talk about one-sided limits. In the previous example, I talked about the left side of f of x and the right side of f of x at x equals 1. That's pretty much what one-sided limits are. So here we have the limit of f of x as x approaches c from the negative side, which is the limit from the left. This is pretty much the left side of f of x at x equals this specific c value. And the limit of f of x as x approaches c from the positive side is the limit from the right. And that's pretty much the right side of f of x at this specific x equals c value. Notice that the minus and the plus sign are superscripts. They're kind of in the position of where an exponent would be. Go ahead and pause the video and copy this down. Now, understanding these one-sided limits is very important because this plays a huge role when finding limits. The limit of f of x as x approaches c exists if and only if the limit of f of x as x approaches c from the negative side equals the limit of f of x as x approaches c from the positive side. Pause the video and copy this down, and while you're copying it down, think about what this means. Okay, let's look at another example. Consider this piecewise function. Here we have f of x equals negative x minus 1 if x is greater than negative 2, and x plus 3 if f of x is less than or equal to negative 2. Go ahead and pause the video and draw this graph. So hopefully your graph looks like this negative absolute value function, or this negative absolute value graph. And what I want you to consider is the limit of f of x as x approaches negative 2. So x equals negative 2 is right here. And if we consider the left side of f of x, there it is. Notice that the left side and the right side of f of x seem to approach the same value at x equals negative 2. That output value is 1. So the limit of f of x as x approaches negative 2 is equal to 1. That's your answer. And I'll go ahead and stop the video here.